Hello, this is Mr. Stansbury. I'm going to take you through the notes on tangents. At the end of this, you should be able to say, I can find the equation of a tangent to a function at a given point. Okay, so first off, tangent to a curve at a point A is the best approximating straight line to the curve at point A. So let's say this is point A, and you're basically hitting that. It's that line that just touches the curve at that point, a straight line, right? So again, a good example of that would be, say, this could be a basketball resting on a table. It's a slant table, but you get the idea. Okay, so that's the tangent line there, and you try to find the either like the slope or the equation of the line. Same thing here. Here's our, we'll call this point A here, and that's the line that just touches that point. Okay. And then also these can both be these points of A, the tangent points right here. So at the top right there, at the bottom right there. Okay? So let's put that into a little practice here. Example 1, find the equation of the tangent to f of x equals 2x squared minus 3, where x equals -1. So equation of the tangent. So that's going to be y equals mx plus b, right? We got to figure out the slope and the y-intercept of that tangent. Okay, so first off, if we're coming up with a tangent, and this is the equation, let's do the derivative. So f prime of x is going to equal 2 times 2 is 4. Subtract 1 from that, and that's 4x to the first. And then the derivative of any constant is just 0. So here's our derivative function. And it says where x equals -1. So we're going to simply plug this -1 in here to the x, and that will tell us what the slope of that slope of the tangent line is, right? So f prime of -1 is 4 times -1. So the slope at -1 essentially is what that's saying is -4. So for our equation here, y equals mx plus b, that's what we want to end up with. I would suggest using y minus y1 equals m times x minus x1. But we do know that the slope now is -4, right? And then we're going to do x minus the x term and y minus the y term here. Okay? We do already know that the x term is -1, so it's x minus -1. If we want to know what the y term is, always take the x and plug it into the original equation here. So we have 2x squared minus 3. If this -1 goes in for the x, we get 2 times -1 squared minus 3. -1 squared is 1 times 2 is 2. Minus 3 gives us -1. So that's what the y is going to be. So we get -1 there as well. And now we can simply simplify this, and away we go. Y plus 1 equals, distribute this -4 to both parts. A lot of people forget to distribute it to the second piece over here. So -4 times x is -4x. -4 times 1 is -4. Subtract 1 from both sides, and we get y equals -4x minus 5. That is the equation of the tangent. To this equation, when x is -1. Okay? So just so you can kind of get an idea here, here is -1, so the tangent point is going to be about right here. So if we're drawing a line there, it's definitely a steep negative line, hence the -4. And then apparently it's going to run in right about -5, wherever that is. I think it's there, somewhere in here. Anyway, okay, just so you kind of get an idea of what we're looking at there. Okay. Let's take a look at our second and last example, but before we do that, let's take a quick comedy break. Example 2, consider the curve y equals -x cubed plus 4x squared minus 3x plus 1. Find the equation of the tangent of this curve at the point where x equals 2. Okay, it's just like what we did on the last example. So For A, we're going to want to have y minus y1 equals m times x minus x1, right? So the parts that we need to fill in are the y1, the m, and the x1. We know that the curve, it's where x equals 2, so we do know that our x1 there is 2. So to say find the y, we plug our 2 into this equation here. So then y is going to equal negative, and this is going to be 2 cubed plus 4 times 2 squared minus 3 times 2 plus 1, right? So let's see, that's negative 8. 2 squared is 4 times another 4 is plus 16 minus 6 plus 1. So that is what, negative 3? Positive 3, right? Because 8 and 16 is negative 14 plus 17 is plus 3. So y equals 3. I probably shouldn't have done this right here because now it doesn't give me room to solve. That's okay. We'll go over. And then we also got to find the slope. So in order to find the slope, we got to do the derivative, right? So y prime for this here, 3 times, let's just copy this down here so that it's a little easier. So plain old y equals negative x cubed plus 4x squared minus 3x plus 1. So to take the derivative, negative times a 3 is negative 3x. Subtract 1 from that. Now that's squared. 2 times 4 is 8. Subtract 1 from that. That's just plain old x. 1 times negative 3 is negative 3. Subtract 1. The x's are gone. Derivative of constant is 0. So here's our derivative function. So if we want to know what the slope of the tangent is at when x equals 2, again, we'll just plug 2 into this. So y prime, or our slope, is going to be negative 3 times 2 squared plus 8 times 2 minus 3. 2 squared is 4 times negative 3 is negative 12 plus 16 minus 3, right? That's negative 15, and positive 16 is positive 1. So let's see. Right. Okay. So then our slope there is going to be 1 here. So then now let's simplify this. We got y minus 3 equals 1 times x minus 2. So it's y minus 3 equals x minus 2. Add 3 to both sides, and we get y equals x plus 1 is the equation of the tangent at the point where x equals 2. Okay, so here's our graph. Looks like our tangent point is going to be about right there. So there's our tangent line right there. Okay, now part B says at what point does this tangent meet the curve again? So probably really the easiest thing here is we know what this equation of this tangent is. We already have the equation in here, so let's just do this. Y equals, we're going to simply enter in our tangent line, which is x plus 1, and we graph that. And look, it's going to kind of help us out here. Look, that's a good sign because it just barely touches right there. So I'm feeling pretty good that that's the right equation. Obviously, if this was cutting through over here and did not look like it was at the right point at all, then we'd have to go back and double check our math here. But really all we need to do now is just find this intersection point right here, right? Which looks like it's at 0, 1, but let's just double check. So we can do second calculate, and we just want to find 5, the intersection, right? So I usually like to move it right off of the intersection point so I can see it move lines. So it's like, is this the first curve? Yes. Enter. Is that the second curve? Yes. Do you want us to guess? Sure. It actually calculates. And there it is. It's at y is at 1, and then e is this weird negative 4.24. E to the negative 15. So remember, whenever you see e to some negative number that's more than like 3 or 4, that basically just means that this is 0. Because really this means take this decimal and move it 15 spots to the left. So it's 0.000000, whole bunch of those. So this is basically 0, 1. So part B, it re-intersects at 0, 1. Okay? All right. That's all we have for tangents. If you have any further questions on any of this, please feel free to ask. Thanks.